function notation. Move off from function notation, alright? This, or this, whatever. Okay, so if your input is x in function notation, your output is your f of x, the function of x. Okay, this is x, this is a function of x. That's what that means. That's why this is the independent and this is the dependent, because this one depends on that. It's a function of that. So independent, dependent. Okay? If you have a function, you can evaluate using, so you got f of x equals 2x squared plus 6, and you want to find f of 2 and f of negative 2. Just put the number in for x. F of 2 would be 2 times 2 squared plus 6. What is that, 14? So f of 2 equals 14. F is negative 2. It's going to end up being the same thing as squaring it. F of negative 2 would also be 14. You just replace that number in. Oh, and you can also do this with variables too. Let's say you want to find f of 3x. We have 2 times 3x squared plus 6. So what's 3x, the whole thing squared? 9x squared, yeah. So that'd be 2 times 9x squared plus 6, or 18x squared plus 6. Put variables in there. You put it, I can put it up. I'll wait for the afternoon class, I'll make them do really ugly ones. But let me ask you this. I do want to ask you this. Would you get, would you get the same thing from those two problems? Do they mean the same thing? No? What? No? Oh, you don't know how to explain it. Okay. I'm with you. Alright, what's going to happen to this x plus 2 on this problem? Right, this is going to be like 2 times x plus 2 squared plus 6, right? And then you're going to have to do this x plus 2, do all that, and you're going to have 2x squared plus 4x plus 4 plus 6. So on this one, like, the entire thing is going into x, right? All of that. What's happening over here? Yeah, I'm just adding 2. Like, I'm just taking f of x, which is 2x squared plus 6, and I'm adding 2. So it's going to be 2x squared plus 8, right? So it's all about what's being included. What's included? So it's about what is being included, like what's in the parentheses, what's happening to the parentheses. It really goes back to that very basic thing, order of operations. Okay? Let's see. Oh, okay. I want to talk about one thing here. Let me give you a couple of these to try. I'm not going to make them too terribly ugly. If I can find what page they're on. See, with this, I can't just like put a bookmark and flip back and forth and take it. I have to flip through it. Alright, so right here, I just have to substitute 2 times 11 plus 1, so that's going to be 22 plus 1. So f of 11 is 23. This one, I like this one because I've kind of snuck in some power rules on you. So f of x squared would be 2 over x squared cubed. What's x squared cubed? X to the what? 6.
Yeah.
Yeah, power to a power, you multiply the powers.
The other one you had, I forgot what it's called.
Multiplication is when you add. Yes. Power to a power, you multiply the powers. When you're multiplying, you add the powers. I add the power. Okay, so right here, that's going to be 3 minus 4 times x minus 6. So 3 minus 4x plus 24 is going to give me a negative 4x plus 27. It's not a very big negative. Negative 4x. Alright. If you didn't get it, you didn't write it down. We're going to talk about domain again for just a second. It's on your quiz, and I just don't feel like we hit it enough. Okay? Like, if I want to know the domain, say g of x equals the square root of 4 minus 3x. And we're talking domain here. Okay? Now, this is an implied domain. We can pretty much there's 2 mathematical sins that we have to avoid. Okay? We're talking real number system. We cannot divide by 0, and we have to keep everything under a radical positive. Okay? We're not going to be taking square roots of negative numbers. Okay? We will eventually, but for right now, we're just talking real number system. Okay? So we have to find a domain here, because there are numbers I can put in there. If I put 2, what will happen if I put 2 in for A? It'll be a negative, right? I can't have that happen. Okay? So when you have to find the domain of a function, if it's under a radical, somebody asked me about this yesterday, that's why I wanted to hit on it, okay? This has to be greater than or equal to 0. It can be equal to 0. Square root of 0 is 0. I'm cool with that, right? We can deal with that. So that leaves you with negative 3x is greater than or equal to negative 4. X is less than or equal to 4/3. Anybody remember why that sign flipped? Why did it go from a greater than to a less than? What? I don't know. Right, divided by a negative. Whenever you multiply or divide by a negative, you have to flip your inequality. Okay? So, this is my domain. Alright? No. This is my domain. X has to be less than or equal to 4/3. So I'm going to, I could do it like this. Or I could say from negative infinity to 4/3. But that's what we do for a domain on a radical. You set it up that it has to be greater than or equal to 0. Okay? The other kind I want to look at, where is it? Okay, I found it. Are you still writing this?
I got a question.
Yes.
I don't understand why you put the X in the line.
This is set notation. All X such that X is less than or equal to 4/3. Yeah. And then this is interval, the interval from negative infinity to 4/3. Alright, let's look at this problem. Let's start with just this one. I don't want to do two domains right now. Okay, I don't have to worry about a negative, an imaginary number on this one. What do I have to worry about on this one? The 0 in the denominator, right? Exactly. So, set it equal to 0. This cannot equal 0, pretty much. So you could set it equal to 0 and then say that's out, or just do it like that. Okay, now I'm giving you a difference of 2 squares. What is that going to factor down to? X plus 1, x minus 1. So x can't be 1, x can't be negative 1. It can be everything else, right? That's what it cannot be. It can be all of infinity up to negative 1. It can be from negative 1 to 1. It can be 1 to infinity. I could jump over these 2 points right here. That's what I have to jump. Okay? It cannot be those 2 bases. If you needed that, let's do like 3 things together. Because x can be less than negative 1. It can be between negative 1 and 1. And it can be greater than 1. That is ugly right there. That looks like hieroglyphics, doesn't it? Yeah, I like that one better. I don't know, they both are kind of crazy. Alright, so we didn't focus on that too much, but that's something that you need to know for the kids. You know, functions can model real-world situations, and when they're real-world situations, a lot of times the domain is defined by what you're talking about. Like if you're buying, I think I did t-shirts yesterday, so like if you're buying t-shirts and you're paying for the price per t-shirt or whatever, like negatives aren't included in that, because you're not going to get a negative amount of t-shirts, and they're not going to pay you money for getting them, right? So, like, that's a domain that's just defined by what we're talking about. And you can also, and I'm going to touch on this too much, but you can also get into these things called like step functions when you're talking about a real world thing. You know, like sometimes we model the population and we'll use a straight line, right? So, or a curved line, even, but still it's connected, it's aligned. Would you move? So we're like, okay, this is how the population grew. And that models how the population grew. But if this right here is like 15.47, or this right here is like 17.2, those can't really like represent actual number of people. You can't have 0.47 or 0.2. So sometimes the domain or the range is determined by what you're talking about. And you might model it with something that looks like this, but it doesn't exactly represent what you're talking about. Does that make sense? Y'all are looking at me like this stairs right now. Good with that?
Yes.
We'll go with it. Alright. Some of you have already done this on your assignment, function arithmetic. F of x plus g of x. Just add them together. Simplify. That would be 6x plus 3. Alright. If you needed to subtract them, you would subtract them. If you would add them, you would add them. If you needed to divide, you would just divide. It's not a big deal. It's really easy. Okay? You can even put numbers in there. Let's see. F times g of 2. So f of 2 times g of 2. You can multiply f times g and then substitute 2, or you can substitute 2 and then multiply f times g. 2 times 2 minus 6 is a negative 2. 4 times 2 plus 9 is 17. So f times g of 2 would be negative 34. You've had some of you have already done these on your homework because I was looking at it yesterday to see how far you've gotten. And some of you have already done this problem. You what?
I'm not very for. So,
yes.
when you just plug it in, like, it says, f of x instead of g of x, when you plug it in like 2?
This one?
No, on one of the problems, I think, there was like,
So f of x and g of x would be 2x plus 6 plus 4x plus 9.
that's it?
F of x plus g of x. Yeah, you just add them together.
And then you
Simplify it. Just add them together and simplify it. On the division, if it will factor, you need to factor it and cancel out stuff that you can cancel out. I've made one up here that doesn't factor. Let me see if I've got an example on here that factors. Nope, I do not. I can try to make one up. This never works out. Alright, let's say f of x is x plus 3. Oh, I'm like, and g of x is 2x plus 6. Okay, here we go. And we have f of x over g of x. So if they don't factor, when you get to right there, that's pretty much all you can do, right? But if they factor, like this one does, then you can do more. Those will cancel out, and you're left with whatever. You're left with 1/2. we're not going to do the difference quotient today. We're going to stop right there. That's quite a bit of your homework. Just getting to there, that was a lot of your homework, and that covers everything that's on your quiz tomorrow. A bad